As you can see, I'm with the University of Queensland, previously with QDAF when we were DPI prior to being DAFI and various other incarnations. So over the past 5 or 6 years, we've been running a large BRD study in Australia, and some of you in the audience certainly have been involved in that. And what we've been looking at is trying to determine what factors predispose some cattle to getting BRD when others don't get bovine respiratory disease. So today I'm going to go through a quick outline of the study. We've got about 20 minutes to do that. As I said before, it's a 5 or 6 year study. I could spend a couple of hours talking on each of the things I'll just brush over today. But towards the end of November, we'll be submitting the final report to MLA, and then it'll be available to industry probably early next year. But at the end of the talk, I'll give a very brief overview of what you can actually do to help us in delivering the results of this project to you. So the purpose of the project was to look at, as I said, BRD across Australia, look at what the patterns are for BRD in Australia, estimate the prevalence of the BRD viruses. So I'm technically a molecular virologist, I'm not an epidemiologist, and they're the statisticians that have run most of the parts of this project. But ultimately what we wanted to do was look at the risk factors for BRD. So those things that would predispose a particular animal to getting BRD and try to quantify that and work out those that we all know about, but can we identify some new ones? And importantly, what factors actually might decrease the incidence of BRD for a particular animal? And ultimately is develop recommendations that you guys can follow in the field. So this is a summary of the project. We had feedlots primarily located where the main areas are. And again, today I won't be identifying any of the feedlots, so their participation in the study was under the understanding of anonymity. And with one located in WA, one in South Australia, but pretty much clustered where you see most of the large feedlots within Australia. We ended up with 14 participating feedlots. And we ended up inducting 170 cohorts of animals into the study. Now, a cohort is a pen full of animals. That's all you need to remember. And you'll see here we have a group 13. That is a group of animals that are together as a group 13 days prior to induction. Now, as I said, I could probably spend a week talking about groups and how they might influence BRD, because we spent years and many hours of my time discussing that. But ultimately, we had just over 35,000 animals inducted into the study. So when did BRD occur? We had a typical, what we think is pretty much standard, so about 18% of the animals across the study got BRD, and that's important because it has to be representative of what actually happens. Primarily peaking around the first 2 to 3 weeks on feed. Again, probably not very many surprises there. 70% of all pools were BRD, and most of the BRD pools were within 50 days on feed. We also saw no evidence of a late spike in BRD amongst those 170 pens of cattle. So there has been some talk, and in my other role, we are making vaccines for BRD, excuse me. And there has been talk over the past decade or so about a late peak, say around about 70, 80 days on feed. We didn't see any evidence of that. Those pools that occurred past 50 days on feed, they were pretty sporadic throughout the remaining time on feed. So what we ended up with at the end of 2010, I think it was, we ended up with a bunch of samples. So we collected nasal swabs and a blood sample at induction, and then another blood sample after they'd been on feed for 6 to 7 weeks. And we also got tissues from those animals that were in our study pens that died, but also nasal swabs and a further blood sample if they were pulled for BRD during the course of the study. Now, because of that sampling regime, we did struggle at the start of the project to get feedlots to become involved, given that we realised that it is a big impost. We also collected management data from the feedlots. So we went there, and those things that you record for your animals, we got all that for our animals that were in the study. And that includes things like the rations, if they had induction, what happened to them during the induction process, things like if pens had shade, all those sorts of things. We also collected the analysed data for all of the animals in the study, so we were able to trace back where they had been during their lifetime, and that becomes more important, as you'll see as I talk a bit more. We did a vendor survey of cattle sold directly to the feedlot, so where we asked the feedlots if they could ask their cattle suppliers if we could come around and talk to them or give them a survey to complete about what had happened to their, what they did to their animals during the, say, such as weaning and those sorts of things. We collected weather data for, some of our feedlots had weather stations, some didn't, and so in the end we just collected available data for the nearest local station. And we've used all this to determine what might affect animals getting BRD. So, as I said, we evaluate the risk factors and use our data to confirm those or refute those. And we also, through this process, have been working with the feedlots that have been involved in the study and the feedlot veterinarians to make sure that we're not going off on some tangent that will never be applicable. So, we now get into what we would consider to be risk factors. So breed is certainly linked to risk of BRD, and I don't think that'll be any surprise to anyone here. Now you'll see here, and this comes up as I go through, it's compared to Angus. So when we consider a risk factor, we have to make one of the groups or one of the categories in that analysis is a reference group, so it's one. And interestingly, we don't really understand it yet, but Murray Greys had a similar risk factor, similar risk to tropical breeds. Now they were a smaller percentage of the population, although the population was really dominated by Angus, and I can't remember the exact figure, but I think maybe 23,000 of those 35,000 animals were actually Angus. Entry weight is important for BRD risk. Lighter cattle are at increased risk compared to heavier cattle. There was a bunch of other animal level factors that we weren't able to, or we didn't see any effect on BRD risk in our study populations. Things like cohort weight, so if you have a weight average for your cohort and animals that might differ dramatically from that, they didn't appear to be at extra risk, although we are working more on that. Dentition, ranges and intended days on feed again didn't appear to be linked to BRD in our study population. There are things that we're still working on, such as sex, which does seem that steers might be at more risk than heifers. So, as I said before, one of the things we did, we collected a lot of samples during the project to have a look at what cattle might be exposed to or might actually have when they're on feed. So we had, at the end of the day, I think we had maybe 150,000 samples to test, and when we gave the bill to MLA to test those samples, they suggested that we go back and have another think about that. So what we did was we ended up doing a case control study, so we took a random sample of those cattle that got BRD and those cattle that didn't, matched samples in terms of breed, those sorts of things, and then tested those to determine what they'd been exposed to seed. So generally speaking, at induction, most of the cattle, or a lot of the cattle had seen BVDV, so bovine pestivirus, PI3 and BRSV, so bovine respiratory syncytial and parainfluenza, whereas a much less proportion of the animals had seen IBR or BHB before. And this reflects the data that came out of the project that was run in New South Wales probably 10 or 15, maybe 20 years ago. When we then retested the second sample for those animals, we saw that their status with regard to those viruses for all of them had changed in those first 6 to 7 weeks on feed. So most of the negative animals had changed to positive, and there was also positive animals that had increased their antibody titer. So they had actually been re-exposed to the virus and increased their response. The question of persistently infected animals, or PI, always comes up in these types of discussions, and about half of our cohorts had a BVDV, a PI animal in the cohort. So and that's considered to be the key reservoir of BVDV. Now, as I said, I'm a virologist, so I could talk about this forever. What we've been able to show is that if your cattle coming into the feedlot, and it's not that surprising, if they have PI3 RSV or BVDV antibodies, they are at reduced risk of getting BRD. So the viruses do matter. You'll see a note there about Rhinogard. Most of the studies in our, most of the feedlots in our study blanket use Rhinogard across their lots. So we haven't been able to assess the impact or the efficacy or anything about Rhinogard in our study because of that. The more viruses an animal's been exposed to, so the more animals it has positive antibodies to, the less likely it is to get BRD. And I think what was also interesting from our point of view is there was no dominant virus. So even though BHV or IBR, sorry, was the most animals were seronegative to, it didn't mean that they had a much higher likelihood of getting BRD. So all the viruses appear to have a similar sort of impact on the likelihood of BRD. Of course, the IBR question is always going to be a bit more complicated because of the widespread use of Rhinogard. And I guess this is just another way of wording that up there, so we'll move on. So this is what we actually found. So towards the end of the project, we decided that we should start testing some of these project samples. So we blanket tested all the samples that came in the last 6 months of the project. So there was about 3,000 induction samples, and there was about 500 odd nasal swabs from hospital cases during that time. And as you can see then, there we're picking up viruses rarely, I guess, at induction, apart from bovine coronavirus, which is a relatively new player on the block. And some of you may not have seen, but last year there was a study published from Peter Kirkland's group in New South Wales linking bovine coronavirus to BRD and some semi-intensively reared cattle down there. So we had an interest in that, so we looked at that. The interesting thing about, even though the numbers seem relatively high compared to the other viruses, that's primarily from 2 cohorts of animals, just from 2 pens. So we're not really sure what that means yet. So in that first testing of hospital samples, we saw proportionally a lot more virus in our hospital cases. And I think that that's important to note that, because that means that if you're pulling animals that still have virus, under the classical model of BRD, they're relatively early in that BRD cycle. So despite what we might hear in a lot of forums, we're actually doing not too bad a job in picking out those cattle that may end up being BRD cases. So based on this first testing, we decided that when we did our more extensive testing, that we would only test the hospital samples rather than hospital induction. And as you can see there, we have picked up a fair bit of BHV or IBR. Again, because these are nasal swabs, it's a possibility that it's highly likely in some cases that they are Rhinogard, that we've actually detected there. And the reason for that is that when we done our pen trials with Rhinogard, the virus stays in the animals for up to 2 weeks, or at least 2 weeks. So that doesn't mean that they're sick because of that. It just means that the virus is still there when they're being pulled. Again, a fairly large amount of bovine coronavirus and increasing prevalence of BVDV and RSV, and not much PI3 at all. So we then tested some of the lungs and trachea that we got from some of our deads. Again, BHV was the dominant virus here, and BVDV. So these are the classical 2 that we always talk about here in the context of BRD. So based on our results so far, we think that still probably hasn't changed very much. We don't know yet if these animals are all the PI animals that have come in, and because they're PIs, that's why they've ended up in the dead pile. So this is a summary of before we get on to some of the other risk factors of the viruses. So we've detected Rhinogard in induction samples. I think that's just cross-contamination. when you're vaccinating cattle, then it's not that unreasonable that the 400th animal that comes through, you might get a contaminated swab. We have it in the hospital samples, but what we want to be able to do is actually go back and differentiate in those samples which is rhino-guard and which is wild-type samples. We've previously done some studies looking at the variation within pestivirus, and based on what we've seen so far, that was about 10 years ago, that situation hasn't changed. So the key thing there is that in the US, the 1A and 1B genotypes are the dominant genotypes in BRD there, whereas by far the dominant genotype in Australia appears to be the 1C. We don't know very much at all about RSV here, and PI3, again, we don't really know much about it. It doesn't appear like it does very much. Coronavirus, it looks interesting if you're a virologist and potentially as a feedlotter, but again, it's one of the things that's only really come on the scene in the last 12 months. So, back to risk factors. Again, probably not that surprising, but if you're inducted in the season affects your risk of BRD. So compared to spring, summer and autumn are the worst times to be inducted into the feedlot. So from memory, the risks was about twice in autumn, but the highest risk was actually in summer, which I guess was a bit surprising to us, whereas you have about 1.5 times the risk of getting BRD in winter compared to being inducted in spring. Weather during the first week on feed, we weren't able to link that to BRD. So we looked at it, we've discussed it with the vets and with some of the operators. We've looked at all sorts of different variations, and we have not been able to find an association with BRD risk. And that includes average wind speed and rainfall. And some of that, we think it's partly because we're looking at data that's been extrapolated from away from the feedlot. In some cases, we weren't able to get data directly from on the feedlot. So particularly things like wind speed, we think there might be, if it's localised, then we're not going to see those associations. The key thing that's come out of the project is how we've used NIS data. So as I said before, we've grabbed the NIS data for all the animals in the study, and then what Karen has done is she's gone back and she's traced those animals back through all the pick changes over their lifetime. And it's turned out to be one of the important findings of the project, and no one else in the world has been able to do that. So what we've demonstrated, one, is that there's no such thing as a typical cohort, how a typical cohort might be put together. We thought, oh yeah, they might get some animals from there, put them together. We saw nothing like that. So animals are sourced from everywhere. We have animals in the study from King Island, from Tasmania. And I guess going on to Sam's thing yesterday, we didn't see any from Hawaii via Canada through the US, but there was some amazing, they move all over the place. One of the things, and we're still working on this, so one of the things is that cattle have been mixed prior to 28 days on the feedlot are going to be at less risk of getting BRD. Now, when we're talking mixing, that means that they haven't been mixed by their vendor. So if someone's bred cattle in that paddock and that paddock and has brought them together, we won't see that in NIS anyway. But it's essentially about when changing picks and how they're mixed, so they're actually coming from different sources of cattle. And you don't really want to see the table that underpins these findings, because we have, I think the last one I saw, there were 16 different categories on how they might be mixed and the timing of that relative to when they're inducted. And so we're still working on that to get that into a format that anyone that's not an epidemiologist can actually understand. That includes me. Moving to the feedlot is also, so what Karen's also done is use that change in pick to estimate travel times, and that's also important. So if you can't get to your feedlot 28 days prior to induction, you're going to be at decreased risk. We also think there's other time periods that are important. It's greater than 28 days, but then 27 to 13 and then 12 to 2 days are also important. But we're not quite sure what those relationships are, and that's what Karen's currently doing is trying to work out and tease out, if you mix in here, what's the optimal way to do that? If you have to do it, how can you best do it to reduce that risk? As I said before, duration of time, so if you travel more than 6 hours in a mixed before induction, you're at increased risk to BRD. Sale yard is always one that comes up in any discussion about BRD. So the interesting thing is, if you go, it's not if you go through a sale yard, it's when you go through a sale yard. So if you go through a sale yard and that then becomes part of your mixing history, then that's going to reduce your risk of BRD when you actually get to the feedlot. And if you think about it, it does actually make biological sense. The more things you've seen before you get to the feedlot, the less likely they are to impact upon you at that key stress time during adaptation. Sale yard in 27 to 13 days increases the risk, but we think that that risk is actually mediated through that it's a mixing thing, so it's actually coming into contact with other animals. Transfer through a sale yard between 12 and induction increases your risk, but currently we don't think that risk is due to mixing. And so we're trying to work out, if it's not due to mixing and potential exposure to other things, then what is actually driving that increase at risk. Pen features. Shared water access increases risk of BRD. So if cattle in adjacent pens are able to share, if they share their water, that increases the risk for BRD. So, I mean, that's something, if you want to take something home from today, if you have shared pens, then you might want to think about how you manage them. Don't put your newly inducted cattle into those pens. Put them somewhere else, move them in there later. Number of adjoinder pens, again, we couldn't find any association with BRD risk. And other pen features such as bunk space, stocking density and pen shade, again, in our study population didn't increase the risk, or didn't change the risk. Location and source of where the cattle are going and coming to. Cattle in southern feedlots are at considerably higher risk. So this was one of the higher risk factors that we saw in the study. But we don't know why that is. We don't, and again, that's one of the things we're still working on. Because with our weather data, weather doesn't appear in the way we had to look at it, doesn't appear to increase that risk. So, and it's not due to things like the type of cattle or how heavy the cattle are. So the model that predicts that has all those sorts of factors in there. So again, something for us to continue working on. Where cattle come from, so as I said before, we have cattle in the study from Tasmania, from King Island, from all over the place, and that doesn't influence the risk of BRD in our study population. Cattle preparation, the key point here is this is only that subset of cattle that we've had vendor questionnaires for, and that's about 10,000 out of 35,000 animals. So prior Pestigard vaccination. So when we're talking about these, it's not at induction vaccination. They were vaccinated on their property of origin, presumably according to the manufacturer's instructions. So we did see some mild, some protective effect of Pestigard and bovilis. And yard weaning, as has been demonstrated in the US and one other study here, it was also protective for BRD. So I guess that's all very well, and this is my last slide, so perfect. The key thing is, as I said before, mixing appears to be a very important part of what predisposes cattle to BRD. So our end goal of the project is to deliver this to you in a fashion that actually enables you to use. So we've been quizzing various people about what sort of tool you might actually like to use and about what you actually know about your cattle when you purchase them. So it's all very well to say if you go back through the NLIS database and check out where your cattle have been, that you can assess what their risk be. But if you can't practically apply that, then again, so we want to try and work out how we can do that. If we had an iPhone app that actually could pull in all the NLIS data and actually make that thing, help you make that decision. And I guess we'd also be interested in hearing from you about if the increase is identified, what would it actually change the way you do things? So we heard some great stuff again from Sam yesterday when he was talking about, I can't remember the pen writer's name that they want to clone, but they focus him on the pens that they think that they're going to have the best issues in. So, are you willing to actually make those sorts of changes? So finally, summary, we don't need to go through that. I'd like to thank the feedlots for participating in our study, the management and of course the staff on the ground that collected all those samples for us. And this, I don't know how you would describe them except for Meg and Lee, those group of people, the feedlot vets. Thanks very much for your attention.